Welcome back to the Everything I Know Garage podcast, the only podcast on YouTube that's going to teach you everything that I know. So please like and subscribe. That helps with the algorithms, helps grow the channel so I can make more videos to teach you everything that I know. So today's show is going to be on three-phase panels. Now, like I've told you before, I am an electrician. I've been an electrician for 23 years. I've been a foreman for about 16 of those 23. Know a lot about electrical, and although this podcast is going to focus on everything that you can do in a garage or anything you can do in the building trades, it will be electrical heavy at times because that's my specialty. So, like I said, we're going to be on talking about three-phase panels. What's three-phase power, right? Three-phase power is not like the power that's coming into your residence or your home. Normally, the power coming to your residence is single phase, two wire. So you have two hot legs, a neutral, and a ground. Now, in commercial buildings or in residential buildings, like tall residential buildings, the panels are usually three-phase panels. Or industrial, like factories and stuff, all work off of three-phase. So, what is three-phase power? Okay, three-phase power is three separate currents that are 180 degrees apart or 1/3 of a cycle apart. So these are sine waves, right? Are three-phase sine waves. Now, three-phase power is more efficient and can deliver more power. So that's why in the commercial aspect, factories and stuff use three-phase power. And your municipalities produce three-phase power uh, to provide that to factory, to a residential building, commercial building. So here's our sine wave. We have our A phase shown in black, our B phase shown in red, and our C phase. Three separate phases. Normally on lower voltage power, it would be 120 volts would be one phase, right? Now, you would need to make 240 or 208 volts, you would need two phases, two separate phases together to power up your 208 air conditioner or your 208 volt pump or something. So I have a model of an old school. Let me show you guys. Let me move this here. Old school panel guts. These are the guts of an old school panel. So let me put this a little closer for you guys to see. There we go. So it's a top fed three lug, three phase panel, right? You have our A phase, which is blue, our B phase, which is red, and our third phase would be black. So this is a three phase panel. Now, black, red, blue, right, is our color code. That's typical of an older building. Now, I did that on this model because this is a very old panel guts, like extremely old. This is probably 50 years old, maybe 50 years, maybe more, right? So that's why I did with the color code. A lot of the old buildings have blue, red, black as their color code. Now, somewhere along the line that changed more to black, red, blue. But if you go into an old building and the color code of the building is blue, red, black, you should always be consistent with that. And your new installation should have the blue, red, black color code. Don't change it because you could mess up. Somebody down the line could think that that's the color code. And when you're wiring up pumps or something, they could reverse the direction in which the pump is running, so always follow what the building is, open up an old piece of switchgear, an old panel and say, oh, okay, the color code of this building is blue, red, black, or black, red, blue. So the reason why I have this example of an old panel guts is this, right? Now, as I bring this closer to you, so as you can see, your A phase is this, right? Now, most new panels don't show you, um, they don't show you the internals of the bus, but this old panel does. So with this piece of switchgear, you can see this is a phase, right? Bus, and it goes straight through, straight down, right? Let me see if I can get more straight. So you can see a phase bus goes straight through, right? Now, the phasing of a panel is A phase, B phase, C phase. A phase, B phase, C phase. So circuit 1, 3, 5. 7, 9, 11, 13, 15, 17, 19, 21, 23, so on and so forth. But what you can see is the on this panel that you wouldn't see on a newer panel is you could see where these little copper ties hit the bus. So this breaker hits the bus, right, of A phase, and comes across and hits the breaker of the other side of A phase. 2, 4, 6, 8, 10, 12, 14, 16, 18, so on and so forth. The same thing for B phase, right? You can see B phase here. So B phase is the red. The bus goes straight through, and you could see the B phase bus off the breaker hits B phase, and so B, B. Same thing for C. C is the black in this panel, and you can see right here it hits the bus. So a lot of people don't know what happens in the internals of their panel guts, whether it be your home or your business, so or a commercial building. The new panels don't really show you what's happening behind it, but this is a perfect example. So, you know, young apprentices or young journeymen will say, you tell them that this is A phase, B phase, C phase, but they can't really see what's happening internally. This helps them learn what is happening internally. Like I said, it's very important to really know the equipment that you're using. It's a really good example. It's all copper detail. I mean, this is extremely old. This got to be 50, 60 years old. This was pulled out of a very old building. So let me see if I can get you a little closer. You can see. So as you can see, we have, there's our bus hitting A phase, B phase, C phase, so on and so forth. A phase, B phase, C phase. Now, it's just a very good example of how to show somebody the internals of a panel guts. Today's panel guts, the breakers are slammed together, and you can't see what's happening in the back. So to a young electrician or even a homeowner, it's really good to know what's happening. Now you want to create. Let's say you want to create 208 or 240. So you have an air conditioner in your home, right? And you go buy a big air conditioner, and it's a 208 volt air conditioner. You run a 208 volt line. You would need two phases. You would need the blue phase and the red phase. 120 volts from this phase and 120 volts from this phase to make 240. Okay, you can't just tap this twice. If you tap the A phase twice, you're just going to get 120 volts because it's the same phase. So you would only have, like I said, you need two phases. Now it doesn't matter which two phases you have. It could be the two outer phases, could be A phase and B phase. It could be C phase and D phase. B phase and C phase. So it just doesn't matter which one you have. Each one will give you 208 or 240, depending on what's coming into your home through your power company. So I just thought this would be cool to show you what's happening on a three-phase panel guts. I do have another set of panel guts to show you. That's pretty cool. Let me show you this here. Just put this on here, there. So this panel guts right here is closer to a more modern three-phase panel, right? Now in this panel guts, I did a little different. I did black, right? Let me back this up a little bit. I did black, red, and blue as the color code, right? That's more typical of a new panel installation. Most new buildings, black, red, blue is your code, right? So here's your phases. I showed you black, red, blue here, but on this side, I showed you blue, red, black here, but on this side I did black, red, blue on your branch circuit wiring, right? Just an example. That's pretty much what a modern. Now this is cool because the buses are marked A, B, and C, which is pretty cool. Now the other thing about three-phase panels or any panel, even your single-phase panel in your home, is balancing your loads, right? Now, it's not a good idea to put heavy loads on one particular phase. So you wouldn't put a heavy load on A phase here and a heavy load on A phase here and a heavy load on A phase here. And then on the other phases, you're not drawing much. So when they say balancing your load, what they mean by is have an engineer should do this with your drawings. The electrical engineer should do this automatically. If they assign a circuit for a piece of equipment, they should take into account that balancing the load across all three phases. Because if you put too much load on one phase, you will draw heat, and your A phase would heat up, or your B phase could heat up, or your C phase. So always try to spread your load around on your breakers, even in your house. Don't put something that draws a lot on A phase here, and then don't and add something on A phase here that draws a lot, so on and so forth, and have nothing going on these other two phases. So it's important to balance your loads on your panels, whether it be your home or a commercial business, even a factory. It's extremely important in a factory because you're drawing a lot of power for big pieces of equipment and stuff. So it's important. So that's another example of a three-phase panel. So I have another example that's pretty interesting for a different panel. Yeah, let me go grab that. I'll take this big heavy thing down. So you can't really tell what's happening in the back of this panel, so you can't see the bus. Here you could see the bus, you could see what's going on. So let me show you this other panel. There we go. Look at this monster right here. Again, we took this monster, super heavy, heavy gauge back box, heavy to lift, heavy to move, heavy to mount. So this is another three-phase panel. This one's bottom fed, right? Now, if you're an electrician and you know anything about electrical, you recognize these breakers, right? So these breakers are a very interesting story behind them, right? And the company that makes them. So this panel was manufactured by the Federal Pacific Panel Company that was around. It was one of the top 5 panel board companies in America for a long time. Starting in 1901 and ran for a long time. They were, like I said, the top 5 in the mid 20th century, right? But there was a problem with these panels. There was a flaw, right? So what we would say in the field is that there was a major problem with these breakers tripping, okay? We would call them federal no-trip breakers or federal house burners because there was a lot of fires caused by these breakers. There was a flaw internally that they didn't trip in a trip situation. So say the breaker was overloaded, it's supposed to trip. That's the purpose of a circuit breaker. Protect the conductor, protect the equipment downstream. But these wouldn't trip. So even if you were tripping a breaker, like you took your circuit to ground, it wouldn't trip. It would act like welding. Like it would like weld against the metal that you're tripping against. So that was a problem because in these houses with old wiring, if there was an issue in the wall and someone cut a wire or a wire decayed or the insulation fell off, it wouldn't trip and it would just keep sparking till it burned houses down. So they're doing some research. They're saying that there was 2,800 fires or up to 3,000 fires a year caused by the Federal Pacific breakers. So it's just an interesting tidbit. And they attributed to dozens of deaths due to the fire. And that's why the Federal Pacific Company ceases to exist today. But you don't know how many buildings that we've pulled these panels or these breakers out of, because they're outdated and because they were a hazard. They were a hazard to homes and hazard to businesses. So it's a little interesting story. It's amazing how heavy this back box is, like heavier gauge steel than any other back box. I mean, and just the panels is super, super thick, all Bakelite, that plastic in here. It's all Bakelite, heavy duty. But it's funny because these breakers are kind of valuable now because if you have an old Federal Pacific panel, I mean, it's kind of crazy, right? Rather than change the panel, if you have a bad breaker, people are buying these breakers to install them in their old panel, knowing that these breakers are a problem, a hazard. So if you have an old Federal Pacific panel in your house or your business, invest in replacing it with something more reliable, like the panel guts I showed you before, more modern, proven to trip breakers. I've gone into a lot of homes where they still have Federal Pacific panels in their house. And so it's a good thing to change it if you can. So we'll get rid of this thing. That's our topic for today, three-phase panels. Hopefully I was informative. If you ever come across this stuff, it'd be good. Even if you're a homeowner or you're an electrician or you're working in a commercial building, and just to know what this stuff is. If you need 208, obviously you need two phases to make 208 or 240, whether it be A phase and B phase or C phase and A phase, so on and so forth. You need two separate phases to create 208, 240 volts, depending on what's coming into your business from the local utility or your home, for that matter. Very important. Thank you for joining the show. Again, this is the Everything I Know Garage podcast, the only podcast on YouTube that's going to teach you everything that I know. Please like and subscribe. It helps with the algorithms, helps grow the channel. Let's get our subscribers up. Let's get our likes up. Even if you dislike it, hit the dislike button. It still helps. Thank you very much for watching, and I'll see you next time.